Hey, how's it going? My name is Alfonso Rabulan. I'm a student here at Jones Technical Institute in the automotive program, and today I'm going to be explaining to you friction forces and the two types of friction forces there are. There's static and kinetic friction forces. Every day we experience these forces and we don't even know it if you don't realize it. I mean, everything from walking, running, rubbing your hands is a type of friction. A great example for friction every day that we experience is when we drive our vehicles. A form of static friction is your tire rolling over pavement, and a form of kinetic friction is when your piston pushes your brake pad here onto the rotor and they slide past each other. And it's a type of friction force as well that helps stop a vehicle. And I have a presentation on a board that's gonna help me explain this more thoroughly, and we'll be right back. To continue on with my explanation of friction forces, I'm gonna name a few more good examples of friction forces. There's, like I said, tires, your brakes, clutches, bolts, and drive belts are all different kinds of friction forces. And now I'm going to explain to you static friction. With static friction, it's the friction where the two contact surfaces almost, you could say, interlock with each other. Like I said, with your tire rolling on the road, it gives you grip to move the vehicle, and it almost interlocks with the pavement so you can move. Another good example of static friction is a bolt going into its thread. It's a great example of that. And here's another good example of static friction. A drive belt on a pulley interlocks here. And now I'm going to explain kinetic friction. Kinetic friction is when the two contact surfaces are basically sliding past each other. Like I said, brakes, brake pads and rotors sliding past each other is a form of kinetic friction. A person going down a slide is a form of kinetic friction. You rubbing your hands together is another form of kinetic friction. Piston in a cylinder is a form of kinetic friction. And on a tensioner pulley, the drive belt just slides past, but still has a coefficient of friction to drive the belt. The amount of friction between two surfaces depends on the finish of the surfaces, the physical properties. That can all change what type of friction force is applied. And static friction is almost always greater than kinetic friction, because kinetic friction doesn't interlock, they just slide past each other. And like I said, the type of physical properties of the two surfaces can change the type of friction force it is. Like, say, when the road freezes over and you drive your car over it, instead of the tire and the pavement causing static friction, it'll cause kinetic friction, because you won't have any grip and you'll just slide. That concludes my video on friction forces. I hope it helps you understand the friction forces more. Thank you.